Welcome to yet another interesting lesson. Today we shall be looking at light. Class, we talked about energy, is it not? Yes. You already know what energy is. Energy is the ability to cause a change. Energy is also the ability to do what? Work. How does energy relate to light? Energy relates to light because light is also a form of what? Energy. Do you get it now? Yes. Light is a form of energy. Remember when we listen forms of energy, we say light, energy. Is it not? Yes. Now, we look at electricity. Electricity helps us to get work done in many ways. It is the most useful form of energy and the most easily converted. Okay, we can convert electricity from one form to another. We can convert electricity to light using your television or your light bulb, for example. We can convert it to sound using your phone. You can convert it to even what's it called? Rotational energy. You can convert it to which form of energy again? Heat energy. Okay, we can convert an electric energy into many. We can convert electric energy into many forms of energy. We can convert it to sound, we can convert it to heat, we can convert it to light, and that's why electricity is so important in our everyday life. Let's look at light. Light and sound are also forms of what? Energy. They can also be used to complete work. Is it not? Yes. Let's look at light, for example. Assuming there is no light in your house, assuming the sun is not giving us light, can we be able to see? No. We will not see anything. Will we be able to do work? No. So you see, light is a form of what? Energy. It is very, very what? Important. Light also travels very fast. Okay? It has been discovered that light travels faster than even bullet. Nothing travels faster than light. Light is one of the fastest electromagnetic what? Radiation. Okay? We call light electromagnetic radiation. Why do we call light electromagnetic radiation? Because the way light is generated, let's use the sun for example, is when light passes through an electric and a magnetic area, okay, it generates this different kinds of energy, and one of this energy is what we call light. Do you understand now? So we call light electromagnetic radiation. Why? Because it is connected to an electromagnetic area. Do you get it now? Yes, it is connected to an electric and a magnetic what? Area. When you combine an electric area plus a magnetic area, a light passes through or it generates light. You have what we call electromagnetic what? Radiation. And this electromagnetic radiation is not only light alone, okay, as I will show you as we proceed. Okay, this radiation can be seen, that is, light radiation can be seen, just like the way sound can be what? Here, is it not? Light also travel. Remember I told you that sound travel in what we call sound wave. Light also travel in what we call what? Wave. Okay, so when light is traveling, we call it electromagnetic what? Wave. Say electromagnetic wave. Electromagnetic wave. Very good. When light travels in the air, it is electromagnetic wave. When it travels in water, it is electromagnetic wave. Okay, we see light through our pupil. Okay, can you see the iris? When you see objects, it's because light enters through the pupil, okay, and move to the retina part. That is why you're able to identify object. If light doesn't enter your pupil, you can't see any object. Do you get it? Yes. Now, light wave are the only wave that the human eye can see. I told you just now that we have what we call electromagnetic waves. It's not only light alone. There are different kinds of energy that have been released, but the one our eye can capture is called light. Okay, light is the only thing. The color are either red, blue, or yellow, and so when they reflect on an object, the object will bounce the light back to our pupil. Do you get it now? Our pupil will now send the message to our brain. Our brain will now identify the color of that material. I told you just now that light is not the only energy that is radiated. Let's say, for example, the sun gives us light. True or false? True. I want to tell you one thing today. The sun does not just give us only light. It gives us different forms of energy. And these energy are called radiations. Okay? Basically, it gives us 7 main radiations, which I'm going to explain to you. Okay? So out of the whole spectrum, which we call this radiation now, all the radiations together is called the electromagnetic what? Spectrum. Now, out of the whole spectrum, the amount of wave that we are actually able to see is only very small percentage. Do you see it now? We can only see this light, which is visible light, and UV, which is ultraviolet what? Light. These are the only two that are sensitive to the human. Okay? You can see X-ray there. You can see gamma ray there. You can see microwave there. You can see infrared ray. You can see radio wave there. Yes, all these are the radiations generated by electromagnetic spectrum. So when the sun that you are seeing every day generating light, always remember that light is not the only energy that is being generated. There are other energies that is being generated which you cannot see. Okay? So this is a list of the arrangement from the lowest wavelength to the what? Highest. Okay? I have the first one, gamma ray. Okay? Now, gamma ray are ray that we even get naturally or artificially in Earth here. Let's say a bomb explodes. When a bomb explodes, do you know it generates light? Yes, is it not? That light also generates this gamma ray. Okay? X-ray, on another hand, we can have that through a machine. X-ray are the ray that are very powerful. We can use it to look through your body. Okay, if I want to see your bones inside your body, I will not use ultraviolet ray. I will not use visible light ray because it can't pass through your body. I will use X-ray. Why? Because X-ray is very, very what? Powerful. Do you get it now? Now we look at another one called ultraviolet ray. Ultraviolet ray is another kind of ray that is closer to light ray. But the difference is that it is more powerful than light ray, which is the visible light ray I'm talking about now. Ultraviolet ray, if it touches you, it causes sunburn. Not only that, it can affect your system. So ultraviolet ray causes what we call mutation. Say mutation. Yes, mutation. It will affect your gene, and then the person will not be able to give birth to a normal child. Sometimes the child will have a problem. Ultraviolet ray does not reach us here on Earth. You know why? Because we have a cloud which is made up of what we call ozone. Say ozone. The ozone blocks the ultraviolet ray, but it allows light to pass through. Are you getting it now? Now, scientists have discovered that because of our bad activities, such as burning bush, using cars that have fuel, the ozone that used to block us from ultraviolet ray now have a hole. So the sun ultraviolet ray is now entering planet Earth. And if it continues, ultraviolet ray will now be reaching us on Earth. We will now be in serious trouble. That is why we are encouraging people to stop using firewood, to stop burning fuel, so that we will not destroy our ozone layer that is preventing or protecting us from ultraviolet ray. If you go to planet Mars, there is no ozone layer. Okay, and therefore the visible light ray have the normal energy and it does not affect us in a negative way. You see it now. We use it to see, we use it to do a lot of things here on Earth. And then we have the infrared ray. The infrared ray is a bit lower. We cannot see them, but we use this radiation to do a lot of things like your phone transfer. Okay, we use this ray to transfer medias. Okay, you have your microwaves, which you use for your your microwave at home. Yes, it uses this energy. And then you have your radio wave. The radio wave are what we use to connect frequency from space to Earth. Do you get it now? Yes. So a short way to remember these 7 important radiations is GX, UV, R. Okay? If you say GX, UV, R, you remember G for gamma ray, X for X-ray, U for ultraviolet ray, V for visible light ray, I for infrared ray, M for microwave, and R for what? Radio waves. You see the code? Yes. Now, you see, as I said earlier, light is very important in our lives. If there were no light, we would not be able to see anything but what? Darkness. Can you imagine a world without or with no light? Just imagine. Okay, like when we have what we call total eclipse, there are sometimes during the day the earth will just go dark. We call that total eclipse. Say total eclipse. The moon will come in between the sun and the earth completely. And then you discover that in the afternoon, everywhere will be dark. It will look as if it is night. Sometimes people used to get scared. They'll think the world is coming to an end. So that is how bad it is when there is no light. So, light is very, very important in our life. This light that is important, how do we get it? Okay, sources of light. Where do we get light from? We get light from two main sources. One is called the natural source. The other one is called the artificial source. Natural source are the one man did not make. Okay, man came to meet them. While the artificial source are the one that are made by what? Man. Do you get it now? Example of the natural source. The number one I'm going to be looking at is the sun. Okay. Now, the sun is the number one source of natural light. Okay. And the sun is actually a giant ball of hot, condensable or incandescent gases. What I mean is that these gases keep burning. Okay. The energy is released produces heat and different radiations, which include the light that we see on Earth. Do you get it now? So the sun is a major source of light. Other form of light are stars. Now, stars are all those other celestial body that can give their own light. Okay, apart from the sun, you can see stars at night, is it not? Yes. We have moons. Moons are not actually light. Okay, they don't have light, but they have a kind of reflecting surface. Okay, when the sun shines on them, they will bounce the light of the sun back to earth. It will not look as if they are light itself. Okay, but the moon is not actually light, but it reflects the light of the sun. And then we have fireflies. Fireflies, those insects, and then glowworm. These are natural source of light. Let's look at artificial source of light. Examples of artificial source of light or light that are made by man include, you can see the different types there, you can see your street light, you can see your headlight, you can see your light bulb, is it not? You can see another street light, you can see police siren, which is also have a red light, is it not? And then fire is another form of light, and then candle is another form of light, and then you see your flashlight, which we normally call your torchlight, is it not? Yes. So all these are examples of what? Man-made light. You can see matches there, is it not? Before the advent of matches, we actually use stone to generate light, which produces fire. All right? Yes. Now I want to look at how light behave. The way light behave is known as the properties of what? Light. There are 5 major properties of light we'll be looking at today. The first and most important one you must know is this: light travel in a straight path. Okay? If you do nothing to light, take for example, you take a torch at home and point the torch and put it on. What do you discover? It travels straight. Does it bend? No, it travels straight in the path that you place it. So that is the first property you must know about light. Okay? The first important thing you must know about light is that light travels in a straight path. Okay? We can see that when the clouds are no longer blocking the sun. Is it not? Yes. The rays of the light are able to travel to their destination. True or false? True. The rays of the light are able to travel to their destination. Is it not? Yes. So we actually see with our eyes that the beam of light is indeed straight. It is not bent or distorted in any way. Therefore, when there are no obstructions, light will always travel in a straight path. Okay? You can see different lights. Can you see it now? Traveling in what? In a straight path. Do you get it now? So light travel in a straight path. Some light sometimes is absorbed by water. What do I mean by absorbed by water? The light will enter the water and then you will not see it again. It just goes straight to the water. Okay? At the same time, some light will bounce off. Okay? As some are entering the water, some are bouncing back out of the water. That's why when you look at the water on a sunny day, it sometimes affects your eye. Is it not? If you've been to the beach before, you understand what I'm saying. Okay? When you look at the water or even the sand, at times it will reflect back to your eyes. Why? Because some of the light are being thrown back to your eyes. Or picture this: somebody put on a very white shirt in the afternoon is actually looking at you, okay? And you are looking at the person and the sun is shining. If you are looking at the person's white shirt, what happens to your eye? Is it not? It will affect your eyes. That is an example of what we call reflection. Say reflection. So the second property that you must know is that light can be reflected. What do I mean by reflected? Bouncing off another object and entering your eyes. Okay, this is one of the major reasons why we see a lot of things. You get it now? One is called specular reflection. Okay, that happens when light hits a very smooth surface like a mirror. Okay, when that happens, all the light will bounce back to your eye. Do you get it now? But when light hits a rough surface like a rock, some light will bounce back to your eyes. Do you get it? That one is called diffuse reflection. Okay, so when all the light bounces back to your eye, it's specular reflection, or you call total reflection. Okay, but when some light bounces to your eyes, you call that diffuse or scattered reflection. Okay, now whether light is absorbed, that is accepted by material, or whether it is reflected off a material, depends on the nature of the material itself. Is it not? Yes. A mirror will reflect the light, is it not? Why an object like a rock will do what? Take some of the light and return some of the light, or reflect some of the light. Do you get it now? So colors are created as seen by the human eye based on the amount of light they reflect or what? Absorb. So because of this ability to absorb and reflect light, like I said earlier, the color we see are the ones that are reflected. Okay, we'll learn that as we now proceed. The third property of light is that it can be what? Absorbed. We've talked about it already. You know, if you look down on water, you can also witness that some light is absorbed, and passes through the water, outside from being what? Reflected or absorbed. Light can be what? Refracted. That is another property again. So I've told you about light traveling in a straight path. Light can be reflected. Light can be absorbed. We're looking at light can be refracted. Refracted simply means bend. Okay, to bend through a material. Light behaves as if it is bending through a material. Okay, and this is what we call refraction. Look at this setup, for example. Have you noticed this thing? It used to affect you. When you put a straw inside the water, it looks as if the straw is distorted. The reason is because of what we call refraction. What causes this? Now, I told you just now that light, just like the way sound travel in air, in water, and in steel, light also travel in air and in water. But when light is traveling in air, it is traveling very fast, about 300 million meter per second. Okay, it is traveling very, very fast. Okay, it will make the straw look like the first one you are seeing. Can you see it outside the water there? Yes. But when light wants to travel through the water, it will now reduce because of the water. So that reduction is what is making you see the straw as if the straw is actually what? Bent, but the straw is not what? Bent. It is due to what we call refraction. Say refraction. And that is a property of what? Light. It's another property of light. Then the last one I'm going to be looking at is called diffraction. Say diffraction. Diffraction explains that when light travels through a small opening or hole, it will spread out in all directions. Is it not? You've observed that before. Maybe you're watching on this movie. You will see where light is coming from a small hole. Those of you that used to watch Scooby-Doo very well. Is it not? You see light coming from a small hole. Alright? And then because it's passing through that small, once it passes through that small, it will shine to all areas in the house. That is an example called diffraction. Okay? So example I'm looking at here is when the clouds are blocking the sun. even if there is a small opening within the cloud, that small opening is enough to let enough light in to light up a large area on the earth, is it not? Yes. This is an example of what we call what? Diffraction. I believe you understand what I'm saying. There are times where the cloud will be covering the sun. Is it not? They will see a small opening that the sun is passing through, but yet everywhere is also what? Bright. It's an example of what we call diffraction. So things you must know about light is this. Just like the way we measure sound, we measure temperature, we also measure light, okay? I will measure light using what we call what? A light meter, okay? And just like the way you have the unit of temperature to be Celsius, you have the unit of light to be lux, okay? Written as Lx. Now, I told you the speed of light. Light travels very fast, okay? It travels about 300 million meter per second. That is very, very fast, okay? Very, very fast. And when light travels, it is called electromagnetic what? Wave. So when light is traveling in the air, it is called electromagnetic wave. When it's traveling in this water, it's called electromagnetic what? Wave. Light bounces off an object and reflects on our eyes. Okay? And then we see the object clearly. Now, when there is no light, we cannot see anything. Do you get it now? Mirror is an excellent reflecting surface. Why? Because it's able to reflect all the light. Okay? Like I told you before, the reason why you see a cloth the way it is because of the light that the cloth is reflecting to your eyes. It's absorbing the other light. Now you want to ask, is black a color? Black and white are not colors. Okay? I'll tell you why. White appear white because white reflects all the colors to your eyes. Do you get it? So when all the colors are reflected to your eyes, what you see is white. Why black appear to be black? Because it does not reflect any light. It will be taking all the light, just like the way you soak your sponge in water. The sponge will suck the water, is it not? Yes, that is what the black color material does. That's why you put on a black t-shirt on a sunny day, you discover that your body is more hot. Okay? You feel heat more than when you're putting on a white t-shirt. Why? Because the white t-shirt will be reflecting all the light away. Why the black t-shirt will be absorbing, it will be taking all the reflection of the light, and that will make it what? To be hot. That's why you feel heat, and that's why it's not advisable to put on black t-shirt on a sunny day. That now brings us, okay, I want you to watch this video and learn more on this topic. Pay attention to what is light. Pay attention to how light is reflected, okay?
It is a beautiful Saturday morning and Jessie is still in bed. The rays of the sun start to enter her bedroom to wake her up. Jessie opens her eyes slowly. The light from the sun lets Jessie and all of us see the beauty in our surroundings. Light is a form of energy. The calculator Jessie uses for her homework works using the light energy from the sun, which we also call solar energy. The sun is the primary source of light and energy on Earth. But how does light travel? Light from the sun travels through air in straight lines. It moves outwards in all directions. Each line is called a ray of light. The ray of light travels directly into our eyes in a straight line. When Jessie closes the blinds in her room, she cannot see the view outside anymore. This is because the light from outside cannot pass through the blinds. Light travels very fast, at the speed of 300,000 kilometers per second. This means that the light from the sun reaches the Earth in about 8 minutes.
Welcome back from that video. I believe from this topic, you now know that light is a form of energy. Light gives off heat, and then we know the sources of light, and then you know the properties of what? Light. And then you also know that light is an electromagnetic wave. And then we see color as a result of what? The light that is reflected, or the color of light that is reflected to our eyes. That now brings us to the end of this lesson. Remember to complete all other activities in this lesson. Stay safe. I'll see you soon.